Hello, my name is Shyam Kumar Kimini. My student ID is MIT183263. Uh, in this assignment, I have chosen the case study related to Turku Energia, which is utility industry located in Finland. Since my MIT ID is 183263, I have chosen the combinations of 183263 as IP addresses. This network consists of 4 VLANs. VLAN 18, 32, 63 and 13, 7 routers R0, R1, R2, R3, R4, R5 and R6, and 4 switches, switch 0, switch 1, switch 2, switch 3 and switch 4. The wireless network is provided to the IoT devices through the wireless LAN controller, which is registered on the central server, and the DHCP pool is defined there, and the user can access through secure connection. This will address the issue of low security issues ongoing on the current network of Turku, and there were separate OT and IT networks for the Turku Energia on ongoing network, and which is addressed by combining the operational network as shown in VLAN 18. This is the network of production side and the offices of the IT network, which are VLAN 32, 63 and 13 in the different geolocations. And the IT department can visualize all the networks through the remote login, and all the switches and routers are assigned with login details through which telnet connections can be tested. Here in VLAN 18, the IP address is 18.32.63.15 for PC 10. For PC 11, it's 18.32.63.16 and so on. The same is applicable for the VLAN 32. In order to set the VLANs on the switches, the following commands are used: enable conf key and VLAN 18 name for the VLAN is production. And in order to assign the interfaces related to these VLANs, interface range F0/1 to 5, switchboard mode access. Here the range F01 to 5 will assign VLAN 18 to the port range 1 to 5. Switch port access VLAN 18. These are the commands used to assign the VLAN. For the router, the commands used to used to assign IP address to the interfaces are: interface I have written here the interfaces in in my notebook, and for the interface 01, the IP address is 28.32. IP address 28.32.6.3 with subnet mask 255.0.0.0. In the same way, all of the interfaces type S0/2/0, S0/2/1, and S0/3/0 can be done. And for the configuration of OSPF routing protocol, OSPF and process ID 100 is entered, and all of the network ID of the all of the interfaces in the router. For example, for the interface G0/1, the network ID is network 28.0.0.0, and wildcard mask. OSPF routing protocol uses wildcard mask instead of subnet mask, and the wildcard mask for the network 28.0.0.0 is 0.255.255.255, and the area is 0. Hence, here the router R6 is assigned area 0, and this acts as the backbone network for the all other routing protocols and routers in this network. And the backbone routers tries to connect all of the router in the network, and other interfaces are also configured like this. For the wireless network, we can take the IP address of the address of the laptop 0. The IP address is 28.0.0.3, and the default gateway is the IP address of interface G00 of R6, as shown in here. In order to check the whether the DHCP pool is working or not in the wireless network, we can check it by IP config dot slash release IP address. It will release the IP address. Here, as you can see, the IP address is released, and for the renew of the IP address, IP config renew, and the new IP address is also lying in the range of the DHCP pool, which is 28.0.0.3. In order to check the ping from IoT devices to the office network like VLAN 32, 63, and VLAN 13, we can take the ping test. Ping one of the computer from VLAN 63, and the IP address is 218.3 dot